Hello Year 6 and welcome to Friday's maths lesson, and today is Arithmetic Friday, and as you can see our focus skill today is going to be multiplying fractions by integers, which is just the posh mathematical way of saying multiplying fractions by whole numbers. And as we usually do, we're going to start off by exploring some examples together. So we've got an example here that's 1/5 times 4, and we're going to have a look at what happens when we multiply fractions by integers. Then after we've seen the video and we've had a go together, there are some that you can have a go by yourself, and there's some answers there as well, so you can see how you've done. And if you're feeling that you really want to challenge yourself today, then you can have a go at not only multiplying them but writing them in their simplest form, but the video explores that a little bit. So first off, let's explore some examples together. Hello Year 6, today we're going to look at multiplying fractions by integers, which is just the posh mathematical way of saying multiplying fractions by whole numbers. So we're going to start off by having a look at this example here, which is 1/5 times 4. And all this means is you're going to take your 1/5, and you can see I've drawn that out here, so my whole has been split into 1, 2, 3, 4, 5 parts, and I've got one of them. My numerator's 1, that's the red part there. And multiplying by 4 just means I've got 4 lots of that. So here's my 1/5, and then it just means I've got 4 lots of that now. So that would be 2 lots, that would be 3 lots, and that would be 4 lots there. So I've now multiplied my 1/5 by 4, or it means I've got 4 lots of 1/5. And you can see here the size of the pieces haven't actually changed. So on each of these, it's all been split into 5, and we've got one piece of it. So they are still fifths. So our answer is going to be in fifths. We haven't changed the size of the pieces at all, so our denominator will stay the same. And now we just need to count up how many pieces have we got. Well, we've got 1, 2, 3, 4. Because all we didn't change the size of the pieces, so our denominator has stayed the same, they're still fifths, but we've now just got 4 times as many pieces, so our numerator has been multiplied by 4, so we've got 4/5. So let's have a look at another example now. We're going to have a look at what happens when the numerator is greater than 1. So we just had a look at 1 there, so let's have a look at this next example. So now we're going to have a look at 2/7 times 5. Okay, so this time we don't have 1 as our numerator, we have 2. We have 2/7 times 5, and there you can see my whole has been split into 1, 2, 3, 4, 5, 6, 7, and this time we've got 2 of them, the blue pieces there. So again, this just means by taking your 2/7 and you've got 5 lots of that. That's what times 5 means. So there's 1 lot, there's 2, there's 3, there's 4, and there's 5. I've saved you from having to watch me draw them out this time. So now we've got 5 lots of 2/7, and as you can see, nothing has happened to the size of the pieces on each one of these. Each whole has been split into 7, so we're still dealing with 7ths. So the denominator stays unchanged because the pieces haven't changed in size, and then all we need to do is see how many parts we have now. So we have 2, 4, 6, 8, 10. So we have 10/7. We've created improper fraction, and it's perfectly okay to leave it like that because we haven't been asked to write it as a mixed number, we haven't been asked to simplify it, so we can leave it as 10/7. And again, you can see the same thing has happened. Our denominator stays the same because we haven't changed the size of the pieces, and all that's happened is we've got 5 times as many pieces now because we have 5 lots of 2/7. So our numerator has got 5 times bigger, and instead of being 2, it's now 10. When you draw it out like this, it can actually help you to simplify it to a mixed number because we can start moving the pieces around. So if you imagine that we took these 2 pieces here, so I'm going to move those from there to here. So I've moved those 2/7 up there, and now I'm going to take the next 2 from the bottom, and I'm going to move them up here so we can start seeing what this would be as a mixed number. So I've taken those 2/7, and then I'm going to get rid of that one there, and you can see now I've completed 1 whole. And then I'm going to take this last final 7th here, and I'm going to move it onto this bar here. And all I've done is start arranging them so they complete one of our wholes so that we can see what this would be as a mixed number if we wanted to change it. And you can see we'd have 1 complete whole there. And then how many 7ths do we have on the second bar? we have 3. And again, we haven't changed the size of the pieces, so they're still sevenths. So we could turn our 10 sevenths into 1 3/7 if we wanted to. But just to recap, when you are multiplying fractions by whole numbers, you can see our denominator isn't changing because we haven't changed the size of the pieces at all. And all that's happened, so when we're multiplying by 5, we've got 5 times as many pieces that we started with. So our 2 got 5 times bigger to make 10 sevenths. So we're only changing the numerator, and that just gets multiplied by the number we're multiplying by. So hopefully that's helpful. Bye. Now that we've explored some examples together, hopefully you're ready to give some a go on your own. So we've got some examples here that you can see, and it works exactly the same way. The size of the pieces don't change, so we're just multiplying the numerator by the number that we're multiplying here. So it's only the numerator that's going to change. So pause the video now because we're about to go through some of the answers. Okay, so let's start with the first one over here, 2/3 times 4. So we know that our denominator is not going to change because we're not going to change the size of the pieces. We're just going to multiply our numerator 2 by 4. So we're going to end up with 8 pieces, and they are all thirds. Now, some of you might like to challenge yourself to simplify the fractions and turn them into mixed numbers. So you would have got the answer 2 2/3, but absolutely fine to leave it as 8/3. And they're both equivalent, so both answers are fine. Let's move on to 3/4 times 5. Again, they're going to remain quarters. We're not going to change the size of the pieces, so the denominator stays the same, and we're just going to have 5 times as many pieces now. So 5 times 3 is 15, so 15 quarters. And again, for those of you that like to challenge yourselves, it does simplify to 3 3/4. But again, 15 quarters is fine, they are equivalent. 3/5 times 3. Again, they're going to remain fifths. We're not changing the size of the pieces, so the denominator doesn't change. And so we're just having 3 times as many pieces, and 3 times 3 is 9, making 9/5. And if you wanted to challenge yourself, that is equivalent to 1 4/5. 5 6 times 9 then. Again, they're going to remain 6. We're not changing the size of the pieces, so the denominator is the same. And then we're going to have 9 times as many pieces, so 9 times 5 is 45. 45/6 is a very, very top-heavy and proper fraction. And if you wanted to simplify it, you can do it in stages there. So it would end up being 7 3/6, which is the same as 7 1/2 if you wanted to challenge yourself. And next one, 5/8 times 4. Again, it's going to remain 8s. We're not changing the size of the pieces, so the denominator is the same. So we're just going to have 4 times as many pieces, and 4 times 5 is 20. So we have 28s, which you may have simplified to 2 4/8, which you know is equivalent to 2 1/2. And last but not least, 1/2 times 6. They're still going to be halves, and then we're going to have 6 times as many. 6 times 1 is 6, so we have 6 halves, which if you turned it into a mixed number is 3. So that's the simplest form there. So hopefully you did well on those and you're feeling nice and confident now. So it would be time for you to have a go at your arithmetic paper. So don't forget, you have 15 minutes for these ones, and if you're feeling stuck, please do have a look on the Google Drive, because there are lots of how-to videos now. So for example, if you can't quite remember how to do long division, there's a video there, so you can go and just remind yourself if you're feeling stuck, and then good luck with that one. And once you've finished, pause the video here and have a go, because what we'll do is we'll pop the little quiz on, so the BBC one, and I lost my crown last week because I was stumped by one of the number jugglers. So have a go at your test, pause the video, mark it with the answers provided, and please do let your teachers know how you're doing, because they're really interested to see how you're improving. And then once you've done that, unpause the video and you can have a go at your quiz. Bye!
Maths Challenge, Program 3. Hello again, here we are with another Maths Challenge. Yes, it's the quiz that turns mental maths minnows into mental maths masterminds. So, pencils and paper at the ready. Let's call up my super sidekick, Matrix, and ask him for today's mathematical expression.
Difference. In maths, the difference between two numbers is how much you have to add on to the smaller number to make the larger one. So the difference between 6 and 10 is 4.
Because 4 is what you have to add on to 6 to make 10.
Correct.
So get ready for...
Round 1. Beat the clock.
Pencils poised, listen out for today's mathematical word. Question 1. What is the difference between 3 and 13? What is the difference between 3 and 13? Question 2. How many minutes in a quarter of an hour? In a quarter of an hour, how many minutes are there? Question 3. If 1% of a pound is 1 penny, how much is 5% of 1 pound? How much is 5% of 1 pound? Fourth question. What is 1/3 of 18? 1/3 of 18. What is it? Fifth question. How many centimeters in 3/4 of a meter? 3/4 of a meter. How many centimeters? Question 6. If y plus 7 equals 15, what is y? What is y if y plus 7 equals 15? Seventh question. What is the product of 8 and 7? What is the product of 8 and 7? Question number 8. How many faces does a cube have? A cube, how many faces has it got? Question 9. What is half of 11? What is half of 11? And finally, question number 10. How many 9s in 72? Divide 72 by 9. That's it. Time's up. No more writing down because it's time for...
The answers.
Beginning with question 1.
Answer 10.
Number 2.
Answer 15.
Number 3.
Answer 5p.
Number 4.
Answer 6.
Number 5.
Answer 75.
Number 6.
Answer 8.
Number 7.
Answer 56.
Number 8.
Answer 6.
Number 9.
Answer 5.5.
And finally, number 10.
Answer 8.
I wonder how many of you got it right. Give yourself 1 point for every correct answer. Count up your scores for round 1. So, now you've written down your first round score, we can move on with the quiz straight into...
Round 2. The Soggy Summer Fate.
Sounds like a washout to me.
Unfortunately, this year's Maths Challenge annual summer fete was almost rained off. Picture the scene. It's raining cats and dogs, so we have to move everything indoors out of the wet, into a tiny church hall. There's hundreds of people waiting to get in out of the rain, and you and Matrix have been put on the door to collect their entrance money.
How much?
10 pence each. The problem is, once you've opened the doors, everyone tramples in like a herd of rampaging elephants. Now, here comes the first question. So, listen carefully, challengers. You've collected money from 92 people on their way into the hall. And Matrix, how many did you collect from?
I collected from 79 people.
Okay, so that's 92 people. And Matrix collected from 79. What I want to know is, how many people did you collect money from altogether? You collected from 92, and Matrix collected from 79. How many altogether? What's the answer, Matrix?
92 plus 79 equals 171. So there are 171 people who paid to get into a very crowded church hall.
If you got the answer right, you can award yourself 5 points. Any other answer gets no points at all. Now, you've also got to run a stall. So, best get over there straight away. Whew, now, this is a white elephant stall. It sells all different bits and pieces that people have given away because they don't want them anymore.
I see.
Right, here's your next question. To start off with, you have £5 worth of change in your till. Now your first customer comes along and buys a battered old guitar for £4.50. You add that £4.50 to the £5 that's already in the till. How much money is in the till now? Right, keep the answer in your head. Your second customer comes along and buys a second-hand CD for £2.25. You take their money. Work out in your head how much money is in the till now. Remember the new answer in your mind. All right, here comes another customer. You sell them a pile of old comics for just 50 pence. You put that money in the till too. Work out how much money is in the till now and write down your answer. Time for the answer then, so that's over to Matrix.
To begin with, the till contained £5. The first customer paid £4.50, making a total of £9.50. The second customer handed over £2.25. So after that, there was £11.75. The final customer gave 50 pence. That means that the total amount in the till was £12.25.
If you got £12.25 as the answer, you scored 5 points. No other answer will do. Count up how many points you've got so far from rounds 1 and 2. I wonder how many of you have got the maximum points so far? A few, I should think. Well, now's your chance to increase your score even further, because it's time for...
Round 3. Juggling numbers.
So a real chance to improve your score now as you get 10 points for each correct answer in this round. Okay, here's how it works. Matrix, start juggling numbers.
15, 3, and 2.
Which you have to juggle around using any of the 4 mathematical operations: addition, subtraction, multiplication, or division, to try to get the target number, which in this case is...
9.
Thank you, Matrix. So, using only the numbers 15, 3, and 2, how do you make the target number 9, Matrix?
No problem. 15 plus 3 equals 18. 18 divided by 2 equals 9.
Correct. Now the rules are that you get 30 seconds thinking time. You are allowed to write down the 3 numbers and the target number. So, pick up your pencils, ready to write down your 3 numbers.
7, 2, and 4.
7, 2, and 4. And the target number, Matrix?
30.
Okay, 30. You've got to juggle the numbers 7, 2, and 4 and come up with the target number 30. Start working it out in your head now. You've got 30 seconds to come up with the answer.
Ten seconds to go.
Time's up. Jot down your answer quickly now if you haven't already done so. Then Matrix can tell us the answer.
7 multiplied by 4 equals 28. 28 plus 2 equals 30.
There we are. Easy when you know how. 7 multiplied by 4 equals 28. Plus 2 comes to the target number of 30. 10 points for that answer. If you think you've discovered another way of doing it, then ask your teacher to check it when the quiz is finished. Well, if you didn't manage to juggle those numbers, maybe you'll do better with our second number juggling question. Matrix, what are the numbers this time?
5, 18, and 3.
Write those numbers down. 5, 18, and 3. And what's the target number, Matrix?
11.
Write that down too. So, now you have to try and make 11 using only the numbers 5, 18, and 3. You've got 1 minute to do it.
Thirty seconds. Ten seconds.
I've got a feeling that caught 1 or 2 of you out. Matrix, give us the right answer.
You need to start with the number 18. Divide that by 3, giving you 6. Then add on the number 5. 6 plus 5 equals 11.
Which was the target number? So, 10 points to you if that's how you did it. And don't forget, if you think you've found another way of reaching the target from those numbers, ask your teacher to look at it for you. Well, that was the last quiz question for today. As far as Matrix is concerned, it's...
Keep juggling those numbers.
and...
Goodbye.